Hey guys, it's me, Brendan. Um, let's see, at 1:40 in the morning, I'm going to teach you a little bit of calculus. This is for homework for my math class, so if you hate math or don't want to watch this, I don't blame you, so don't watch it. But for those of you who are still watching, congratulations. You're about to possibly learn something. Okay, so this is what I'm going to be doing is doing number one of the 2005 AP exam, the free response portion of the 2005 Form B AP exam for AP Calculus BC. Well, this is an AP question, but yeah. So I'll just teach you and explain it. So let's take a look. Okay, so let f and g be the functions given by f of x equals 1 plus sine of 2x and g of x equals e to the power of x divided by 2. Let R be the shaded region in the first quadrant enclosed by the graphs of f and g as shown in the figure above. Before we get started with this question, it is recommended that I get my trusty calculator, turn it on. Okay, you didn't run out of batteries, dude. You want to turn on for me? Yay! Oh. Now, what I preemptively did was put in the equations, graphed it as such. So we want to figure out where they intersect. So for that, we go to second and calc. We go to intersect. Then the first curve, just like set it there. And my guess is that it's there. And sure enough, it's that is too small for me to read. Here I'll just use my own graphing calculator and just punch in the number 1.135669. Okay. Jeez. Sorry guys, a little bit tired. Oh my gosh, my stomach hurts. Let's see. Yes, it intersects at x equals, well, what the heck am I doing? Graphs of f and g intersect in the first quadrant at st, which is 1.13569, 1.76446. Now, this is saying that f of x and g of x intersect right around this point here. So that will most likely, looking at all the questions, most likely be our second bound. Yeah, seems like it. Okay, so we have to find the area of R, and for that, we have to set up an integral. Whoop-de-doo! Okay, quit. Okay, so what you'll want to do is you want to go to math. You want to go to integral. An integral is really just taking the sum of two functions, I do believe. Wait a minute. I probably should have said something. Oops. We'll just put in the number 1.1. You didn't put in a point, you dingleberry. I don't know if I'm gonna have to make two parts of this video, so just hopefully I get it done early enough. Jeez, my stomach is really hurting. Jeez, I just ran track, but it shouldn't be hurting. Oh, I just noticed. Holy crap. Wait a minute. Before we do that, you get 1 point for the correct limits in an integral in A, B, or C. So if you find the two bounds correctly for all integrals, you get a point already. That's easy. Okay, so we want to do f of x, since f of x is the upper function and g of x is the lower function, so it would be from 0 to 1.13569. And I just got a brain fart. B y1 minus y2. We should get 0.429. Yep. Now, my teacher always says use 4 decimal places. So our answer is 0.4291. Okay, you're welcome. Okay, I'm saying welcome to myself. I don't know. I'm tired. Don't judge me. Okay, so that is the area of R is 0.429100, whatever it's at, 9198. Okay, so B asks for the volume of the solid when R is revolved about the x-axis. Now this is a little bit interesting. You might be asking, well wait, this is two-dimensional. How are you going to find the volume of a two-dimensional object? You're not. You're taking this, and let's say this is our x-axis and this is R. You're taking R and you're revolving it around the x-axis to form a solid, sort of like a donut. Yeah, so what we want to do is we know that the derivative of volume is area, and the derivative of the volume of a sphere is the area of a circle. So what we have to do is, since the area of a circle is pi r squared, we have to insert pi. That was a big mistake. Fuck. Hold on, give me a second, I'll be right back. Okay, so I have actually set it up now correctly without making a mistake, because, you know, I'm totally a perfectionist and I never make mistakes. Except for, you know, living. Okay, so the derivative of volume is area. Since it's the area of a circle, it'd be pi r squared. So pi would go on the outside of the integral. We still have our same bounds from 0 to s, or 0 to 1.13569. Then our r's, our radiuses, our radii is actually the functions. No. Okay, so we take our function, square it, r squared minus r squared. We should get 4.2665. And that's your answer to part B, and that's how you do it. Let's see, I have a 15-minute limit. I could try C. Okay. Why the F did it? Wait. I didn't do nothing. What? What are you talking about? Okay. So let's see. The region R is the base of a solid. For each solid, the cross sections perpendicular to the x-axis are semicircles with diameters extending from y equals f of x to y equals g of x. Find the volume of the solid. This may sound as complicated as heck. It really isn't. Even though it's part C, it's still easy. Okay, so here's what's going to happen. Pretty much what it's saying is if you take this and you lay it down, R is the base of a solid. R is right here in the palm of our hand. And there are little cross sections sticking out of it, perpendicular to the x-axis. So you got a cross section, cross section, cross section, cross, 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 cross. Okay? Same thing here. Cross, 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 infinitely. So it's saying from y equals f of x, y equals g of x. So from here, it'd be just a bunch of cross sections until we reach g of x. And then they are semicircles. They're not circles, they are semicircles. Keep that in mind. So we have to find the volume again. Okay? So you're like, okay. Well, he's like, what's the why do we need to do? What's the point of a semicircle? Here's why. I might actually have to pause it because I only have 4 minutes left. So let me create the function and then I'll get back with you. Okay. So I have the equation. The bounds are still the same. 0.13569. And then you're like, hey, the equation looks funny. Well, you're right, but you might be a funny person. Sorry, my mom walked in. So our equation is pi over 2, and then in parentheses, f of x minus g of x over 2, and then outside the parentheses is an exponent of 2. Now, why divide by 2? It's a semicircle. It says cross sections. Yeah, the cross sections perpendicular to the x-axis are semicircles. So you had to find the derivative of volume, and then you had to divide it by 2 since they are semicircles and not full circles. So you still do pi and then y1 minus y2 squared. And you should get 0.0 something. 0.0776. If you want to include the 5, it's 07765. That's how you do C. And that's how you do it. You find it's pretty much finding an integral and then an answer. And finding the correct limits, which are just the same. So yep, that's it. Oops. Go back. Okay. So that should be it. Okay, I can close that. Okay. That's how you do calculus, guys. Friends who are not in calculus and some who are probably still some who are still not in high school yet, but will be soon. This is what you're going to be doing if you choose this path. If you choose the calculus path, this is what you're going to be doing. And this determines if you are good at math or not good at math. And I think I have already found my answer. So, I want to say congratulations to the teams on track, even though the school who hosted it may or may not have cheated by may or may not disqualifying their own runners during that meet. That's the only reason why they won, I swear. I mean, it wasn't because we sucked, it was because they sucked at sucking. But, yeah, it was fun. Let's see, I'm probably gonna post, Jesus, pardon me, excuse me, whatever. Probably gonna post part 50 right about now, so, yeah, and I'm starting to hit my limit as well. I got, hey, limit. I'm getting less than 25 seconds, so. Yeah, so just check my channel out, check out my other videos. They're a lot more lively than this. And, I guess I'll see y'all later. Dee Dee, doing it done. Signing off.